In this video, we're going to look at how to design a function that consumes two arguments, both of which are described by a one-of type comment. Okay, so a function, for example, that consumes two lists of strings. That's what we're going to do in this video. But actually, something much more important than that's going to happen. What's going to happen in this video is we're going to see that we can use the type comments to reason about the actual behavior of a function. We're going to take one more step towards designing a function based on a model of the function. And what I mean by model is a more abstract representation of the function, or a less detailed representation of the function, that tells us enough about what the function has to do that we can make some real design decisions based only on the model. In some sense, we're going to be programming using a picture before we're programming using code. So here we go. The problem in this file is that we're asked to design a function that consumes two lists of strings and produces true if the first string is a prefix of the second. So if, for example, we give it list AB and list ABC, then it's going to produce true because AB is a prefix of ABC. But if we give it list AB as the first argument and list A as the second argument, then it'll produce false because list AB is not a prefix of list A. The first part of list AB is the first part of A, but once you take the A off the front of both of them, you now have B in the first list and empty in the second list, so that's not a prefix. So here we go. Let's design the function. As always, we'll start with HTTF. This function is going to consume two arguments that are both lists of string, and it's going to produce a Boolean describing whether one is a prefix. So we'll say produce true if list A, we'll call it, is a prefix of list B. And to make it clear which is which, I'll say prefix equal list A, list B right here. There's my stub. So now I've got to start doing the check expect. But before I do that, because this is a function that consumes two arguments, both of which have a type that's described by one of in the type comment, we don't yet have an example of designing a function like this, and we can jump ahead now to knowing that we are not going to know how to template it. And it might not even be clear what we should do for tests. So here I'm going to introduce a new concept called a cross product of type comments table. And here's how it goes. Both of these types are list of string, so both of them have two cases in their one-ofs. So what I'm going to do is I'm going to make a table that's going to have two rows and two columns, like this one. This is called a cross product of type comments table. It works for two arguments. And the idea here is that I'm describing the type of argument A across the top, and I'm describing the type of argument B down this column. You could do it the other way. The important thing is just to label which is which. So I've got A across the top and B down the side. And the key thing about this table is that what I've put on the edges, what I've put across the top here to label the columns, and along the side here to label the rows, is the cases of the one-of type comments. So jumping back to the type comment briefly, even though I know you have it memorized by now, list of string is one of either empty or const string list of string. So I just took those two cases and I popped them into the table here, empty or const string list of string. And since argument A is a list of string and argument B is a list of string, we get the same thing here as we get across the top. I just want to stress you can use this design approach even if the two types are not the same. So if you had list of string and list of number, you could use this. If you had list of string and binary search tree, you could use this. The key thing is that both types have a one-of in their type comment. So we've got the cases of the one-of type along the axis. And now let's see, what is this table telling us? Well, let's see, this case here, the empty case, well, that's the case where both lists are empty. It says list A is empty and list B is empty. This table, in some sense, in this box, is where we're going to talk about both lists being empty. In this box, what's happening is that list A is not empty because list A is const string list of string, but list B is empty because list B says empty. This box is the box where list B is not empty. Right here, list B is not empty, but list A is empty. And this is the box where both lists are non-empty because both of them are const string list of string. Now this table is going to help me generate tests. Because this table tells me what? Well, this table tells me I need at least 4 tests. I need to at least cover these 4 cases, and I may need to cover some more as well, but I at least need these 4 cases. So what I'll do is, through the magic of video editing again, I'll put the cross-product table right over here to the side as we're working. If I was doing this for myself, I would have written it on a piece of paper and look at it as I'm going. And I know I'm going to need at least 4 cases. So I know I'm going to need at least prefix equal something, 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 and I'm going to need at least 4. So let's see. The simplest case is the case where they're both empty. If both lists are empty, then the answer is true, because empty is a prefix of empty, right? A list with nothing in it matches a list with nothing in it. So that's if both lists are empty. Now let's do the case in the upper right, where list A is not empty, so it's going to be something like list X. But list B is empty, so it's going to be something like empty. Well, what's the answer in that case? Well, if list B is empty, then list A is definitely not a prefix of it, because list A is longer than list B. It can't be a prefix of it. So this is going to be false. So that's that case. Now let's do the case in the lower left. So this is the case where list A is empty and list B is not empty. Well, what's the answer in this case? Well, in this case, the answer is true, because empty is a prefix of any list, because the way to think about it is all the elements in empty come at the beginning of list X. And that's true because there are no elements in empty. So all of them do, all the ones that are there come at the beginning of list X. So this one's true. And now what's this case? Well, in this case, both lists have something in them. So that could be a case like this. That could be a case like that. Well, in that case, it's true. The first list is a prefix of the second, but I think there could probably be a bunch more cases, so let me make some copies of that case. Let's see, if it's X and Y, it's going to be false, because the list X is certainly not a prefix of the list Y. And we should probably use the rule about things at least too long. So let's here say list X, Y, and that is a prefix of X, Y. And let's do one where we've got list X. Let's do one where it starts out being a prefix, but then it isn't later. And let's do one where it's just too long to start with. We might not need that one, but let's do it anyways. Actually, let's do one where it's too short, but okay. Let me see if I've got these right. Oh, this one I forgot to change to false. This should be false. And this should be true. And this last one where it's just too long, that should be false. So it's worth going through these again to be careful. Let's see, that one is empty, empty is true. That's the upper left. That one is the upper right. False because A is longer than B, so it can't be a prefix. This is empty, not empty. This is true because the empty list is a prefix of anything. And then here's one where they both have elements and they do match. Here's one where they both have elements and they don't. Here's one where there's more than one long, but they match. Here's one where they're more than one long. They start off matching, but they end up not matching. Here's one where one is shorter, and here's one where one is longer. So that's a bunch of tests. As always, as the functions get complicated, we might end up needing more, but we've been able to generate a set of tests here pretty systematically. And the reason we were able to generate them so systematically is because the first thing I did was to generate this cross product of type comments table. That table really kind of gives me the lay of the land. It tells me, look, you need at least 4 tests. When we look at these here, the first test corresponds to a 1 box, the second test is the upper right box, the third test is the lower left box, and then all the remaining tests are the lower right boxes. Of course, in the recursion, they'll end up being some other boxes, but at least as they start out in the lower right box. So that's pretty good. We've generated a bunch of examples using the cross product of type comments table.